All right, recording. We got the morning math people here, but we're going to just keep going because the test is not going to delay itself, right? All right, so now why move it? There we are. So this is a multi-step equation. So we're going to solve the equation. Right, Gabrielle? Okay, so here we have the equation. So we want to distribute, right? Hopefully when you see a number in front of the parentheses, you say, oh, I should distribute that. You see it? Do you say that? Okay. And then hopefully when you see the minus number, you don't just distribute the 2, but you distribute the -2. If you don't do that, you're going to get it wrong. So that's 5x minus 30, and then the next one would be -2x. -2 times 3 is -6. So distribute, then combine like terms. So we see 5x and -2x. That makes 3x. And then in my class, we always like to take the numeric terms and move them all to the right side. And when they go over the equal sign, over the line, we change the sign. So that -30 on the other side would become +30. And then -6 would become +6. And so now we just add 12, 30, and 6 together. So 12 and 30 is 42. And then the 6, and so that is 48. So you end up with 3x on the left equals 48 on the right. And now, what do we do? No, we don't add. No, we divide. There we go. Pay attention. Divide both sides by 3. Bam, it's gone. What is 48 divided by 3? We gotta know 48 divided by 3. It's not 10, 11, 12, 14, 12, 18. Huh?
15.
You said 15?
It's 16.
It can't be 16.
I
It
was
can't be 16.
16. I was thinking about it.
All right.
I just had to get the back part
There you
right
go.
because I was like 6 times 3. Okay, 8.
Yeah, it's 6:44 in the morning, so it's 16. Okay, let's move on. All right. So you can even here. You can have a seat there. Back here, right down there.
Okay.
No, have a seat.
Have a seat.
Right down the crowd. I
Oh, I
didn't
can't
say.
see the problem.
Well, sit there.
Okay.
Because I'm recording. All right. So you're.
Oh, okay. That's okay.
Which of the following numbers are rational? All right. Pay attention. Rational numbers can be written as a fraction. I mean, that's the definition. But if you are using a calculator and you want to spot a rational number, rational numbers have 2 characteristics. They end or they have a pattern. But beware. 1/7 looks like it's irrational. Look at that. 1/7. I divided 1 by 7. It does not appear to have a pattern. So an even better way to know that rational is to know what the irrational numbers are. And everything that's not irrational, is rational. So what are irrational numbers? Irrational numbers. Pi is irrational. Yep. And any non-perfect. Any non-perfect.
Is it something that you can't put in a fraction?
Yeah. But that's what I was saying. That's right. So, but it's easier to think about like pi there's another one called E.
Oh, I don't
Yeah. But any non-perfect square root. For 8th grade math, if you know that all the non-perfect squares are irrational, you're gonna get the question. You gotta write down this. I'm gonna erase it.
Okay.
I'm gonna have to watch the video.
All right.
So is negative 72 a non-perfect square root? No, so it's rational. Rational. Oh, the square root of 6 is not a perfect square, it's irrational. The square root of 16 is rational, it's 4. The square root of 5 is not a perfect square, so that's irrational. And the square root of 100 is 10. So the answer is C and D. All right. Moving right along. I got you can't. Otherwise, people watching the video won't feel what they do. You have to keep it down when someone's recording. All right, I don't care if it's tie-dye day. All right, so here we have the graph of a linear function. What form is it in?
Standard.
It's in standard form. You see, you need to know your forms. What's the other form?
Slope.
Yeah. So again, we use all the questions, not just to say, oh, the answer is A. Yeah, I reviewed it. No. But we use all the questions to tell us the different topics that will be on the test. So what topic does this tell us will be on the test? Graphing in both forms. Slope-intercept and standard. Hey guys, I can hear you all the way over here. You know what that means? The YouTube people can hear you all the way over here. All right? You want your conversation to be on YouTube? Yeah? Or make sure it's good. Mathematical. All right. So this is in standard form. So how do we graph in standard form? You remember how to graph in standard form?
I think, wait. Yeah.
You find the x-intercept and the y-intercept. So we find the x-intercept and the y-intercept. X-intercept is where the
So in this case, it would be
x equals negative 3.
Yeah, so like the x-intercept part.
That's what a lot of, oh yeah, that is right. A lot of people think the x-intercept is 1 and the y-intercept is 3. But no. To find the x-intercept, that's when the y is 0.
Yeah.
So you just get rid of the y. And to find the y-intercept, what equation would you set up?
3y equals negative 3.
There you go. Did you hear that? Find the y-intercept, we set up 3y equals negative 3. And then we have our intercepts, we have to solve here. That's not too bad. Right. So the y-intercept is negative 1, and the x-intercept is negative 3. So in order to do this question, I get my intercepts, and then I look for the graph that has those intercepts. So it's not B, and A goes through negative 1, but it goes to positive 3. So let's keep moving on. Negative 1, look at that. C goes through negative 1 and negative 3, just like I wanted. So the answer was C. All right. Okay, look at that next.
Oh.
It's okay. It's okay. It's a word problem. It's a word problem about a topic that we in our class are going to get to actually after the MCAP, called scientific notation.
Oh, I know that.
Oh, it's good.
I've known about that.
But even if that's the case, we know our rules of exponents, and we can, this is not that hard of a question to answer. It says the world population is about how many times as large as the population of the country. So anytime you want to find out how many times as large something is, you are dividing. No,
I thought it was one big.
Well, it's multiplication in one way, but if you're going backwards to figure it out, then it's division, right? So how many times as large is the population of the world as the population of the country? So we're dividing. Which one goes on top? We're going to take the world
Oh,
and divide it by the country. So what's the world?
the world is 8 times 10 to the 9th power.
There we go. This is helpful having you guys here for the video. So that slow down. You know?
Yeah.
All right. And then what goes on the bottom?
2 times 10 to the 8th power.
Wow. All right. And so now you might be thinking, well, now I don't know what to do. What are you thinking? It's okay.
Very much.
All right. Let's just take one part at a time. So what's 8 divided by 2?
8 by 2.
4.
Okay. So 4. You can do that.
Yeah.
And then maybe Missy, you remember the rules of exponents. What do we do with exponents in a fraction? Add them, subtract them, multiply them.
Oh.
We subtract them. Very good. So it's 9 minus 8.
1.
1. So times 10 to the first. All right. So 4 times 10 to the first, which is what? What's 10 to the first? 10. So what's 4 times 10?
4 times.
So now we have our answer.
40.
So the answer is 40.
Well, yeah. So the population of the world is. Go ahead.
It's 42.
It's 40 times as large as the population of the country. Don't worry. you still got a
That
whole-
would be a fraction.
Oh, yeah, but you still got a whole nother year.
Learned it early.
Guess he has 1 week.
Yeah.
All right. So let's move on. All right. 10. Oh, good. This looks hard because it's got words. But when you start reading it, this is one of the easiest questions on the test. Reflecting across the x-axis. So remember your breakdown reflection. Reflection rule. What are the reflection rules? We have 2. We can reflect across the x-axis or the y-axis. And when we reflect across the x-axis, which coordinate changes? The y. Very good. And so xy would change to x negative y. Jeremy, you want to guess at which coordinate changes when we reflect across the y-axis?
X.
The x. Yes.
Negative X, Y.
Yes. Amazing. All right. Good job. So we're reflecting across the x-axis. So what is the length of the line segment? Okay. 2, negative 2, 8, negative 2. But let's reflect across the x-axis. So what does 2, negative 2 change to? To positive 2. And what does 8, negative 2 change to?
Negative 8. No, wait. I think negative 8.
No, we're still reflecting across the x-axis.
Oh.
So it's 8.
8, 2. All right. And so this question is asking about the length of the line segment. We actually learned 2 different ways to find the length of a line segment. At this moment, you may not remember either because we're doing a lot of things at once. But it's okay. Let me draw a picture and hopefully jog your memory. So there's 2, 2, 3, 4, 5, 6, 7, 8. Oh, look at that. This is a really easy one. Actually, before I drew the picture, I was not thinking about how easy this was, okay? Because I thought it was an oblique line, like a diagonal line. If it was a diagonal line, we would have had to use the distance formula or the Pythagorean theorem. But since this is a horizontal line, Jeremy, even you,
Yeah.
what's the length of it?
Length is 8.
It's not 8 because it doesn't start at 0, it starts at 2 and it goes to 8.
2.
So subtract
Which would be 6.
6. Yep. Is that one of our choices?
Yes.
Yay!
So
We're gonna pass the 8th grade. All right. You guys have it all written down?
Yeah.
All right. Oh goodness, look at that. You thought it wasn't gonna be on the test, didn't you?
What is that?
What is that?
It's a system of equations.
Oh, I'm not. I can't do that.
It's just, oh, that's
I'm
algebra.
used to placing the actual line myself.
Oh, yeah. So they did it for you.
Oh,
The graph of, this is a system of equations problem. In 8th grade, you have to be able to solve a system by graphing, substitution, and you have to know how many solutions it has. And so this one, they already graphed it for us. So what do they want to know?
They want us to know what is the solution to the system of equations.
Well, that is not a difficult question when the work is already done.
Yes. So
Don't you just have to where they
You find where they intersect. Where do they intersect?
they intercept that.
So at 2, 7.
Two, 7. They intersect. For our YouTube audience,
They intercept that 2, 7.
2, 7. And so the solution is 2, 7.
This
Because
is 2, 7 because the solution to the system must satisfy both equations.
Yeah. There we go. Easy points. All right. And I don't think that you can go back to a question on the MCAP.
No, you
Yeah, no.
What is that?
No, oh, Matt, you could never go back to it either.
You're supposed to be able to do the easy questions first, but I guess.
no.
What, you don't skip, if you skip all the questions, you could.
Huh? You have a question? All right, we're pausing the video. We'll be right back. All right, we're back. So this is another one that we are not going to get to until the end of the year. But that doesn't mean you have to guess and freak out, okay? Because we can use our logical reasoning here. Let's read it. The following scatter plot, okay, so we don't have to know what a scatter plot is, but it's right there. But what is a scatter plot? It is a graph of data. Okay, so instead of just everything lining up in a straight line, sometimes data doesn't do that. So we get what's called a scatter plot. And but you can see that it does kind of have a line pattern?
Yeah.
Like it starts down low and then it goes up.
Always, well,
It's increasing, very good. For 12 days of ice cream. So what do they want to know? Which graph shows the scatter plot with the linear model that fast predicts sales for a given country? Sure. Now you can go before you. Oh, okay. I was like, where are the graphs? So what do you think? Which one? What's wrong with A? A looks like it predicted really well for 12, right? It's right on the money. But then over here at 22, 24, the line is it above or below the data? It's above. And it looks like the data may go out here and the line may get further and further away. Do we want to use this line to predict?
No.
No. prediction would always be too high. You think you had more money than you did, and that's dangerous. You know. Now this one
It's on the lower.
is below. So if you use this model, you're gonna think you have less money.
Which
You're
is-
gonna always be sad and depressed.
Yeah,
When really you have more money than you think you do.
but people won't look at it. Won't look at the chart.
Yeah. Some people like to predict like this. Some my mother-in-law, you know, she sets her clock fast so
So
that she thinks she has less time than she actually does.
that's what my mother does.
Yeah,
She puts it at the time. I'm like, I don't even know what time it is. I have to check my phone.
yeah.
My phone reminds me.
Isn't that funny? Yeah. So this, what do you think about C? Do you guys like C?
No.
It's like they didn't even try. They
It's
just
like-
put a line.
it's just the middle. It's like it's between.
That means your money just stays where it is.
Yeah, it's just gonna stay. It's like
It just stays at
like
what,
every
400?
time.
Yeah, they're saying this is not even anything. They're saying let's just always think we have 400. All right, we're recording, guys. We're recording the 8th grade math MCAP. So have a seat and join in. If you want to be on camera, you can wait. But it'll be on YouTube. So have a seat right there.
Right there.
No, you won't get hit back. You're not gonna be.
You're not gonna.
Just your voice. You're gonna be a star. All right? Get ready. We're gonna go viral with the MCAP practice. Okay? So D, what do you guys think about D?
I think
Yeah.
D is a good graph, okay? Because look, 12 is right on and 26 is right on. So we want to choose the model that is most closely related to most of our points. Everyone got that? We want to choose the model that is most closely related to most of our points. Okay, 13. Go ahead and write down 13. Come on now. Here. Consider to write down 2x plus 3 equals mx plus b. What is mx plus b? Slope intercept, right?
yeah.
All right. No solutions. So, we are just finishing systems of equations. And we know that systems of equations, when do lines have no solution?
Oh, when they're, is it when they're parallel?
Yeah, when they're parallel. No solution. Does anybody know what is the same? What is the same in two parallel lines that makes them parallel? Is it the y-intercept? Are the y-intercepts the same? This y-intercept is not the same as this one.
Oh,
This
that
is-
one's low.
Yeah, this is lower, negative, this is positive. You know?
So that's the X.
Not the x-intercept either. The x-intercepts are bigger. So what's the last component of a line if it's not the intercept? M, which represents the what?
So,
The slope. How many people in YouTube land knew it was the slope that's the same? You know? So that's what it is. The slope is the same. And so we're gonna write that down. Same slope. If we see two lines with the same slope, they have no solution. Okay? Now let's see if Jeremy can do it. If Jeremy can do it, then you guys should be able to. Because he's in 7th grade. All right? You got a year on it. So we're gonna help him. All right?
I was like,
The slope of this line is 2. Right?
yeah.
So what do we want to see on the other side so that they have the same slope? 2. Okay? So does it matter what the y-intercept is? No, just if they have to have the same slope. So which one could be the answer? Could A be the answer? If M was 2, would they have no solution?
no,
they would have no solution. It would be 2x plus 3 and 2x plus 2. Same slope, no solution. What about this one? It'd be 2x
No.
plus 3
No.
and 3x plus, well, I know you know it's not, no, but this would be 2x plus 3. So you might be saying, why does C not work? What do you notice about C? It's the exact same thing.
Oh, but they're exactly. It's infinite.
Yeah, very good. So when the exact same thing, that's actually called infinite solution. So if you guys didn't hear me say it earlier in the video, unless you're gonna watch the video later, we're not just doing the trial book, Kayla, to get C and say, oh, the answer is C, let's just move on, yay, because that's nothing, right? But we want to use each one of these problems to identify the topic that will be on the test, and then talk about that topic in general. Ain't it? All right, so C is not right because it would be infinite solution, and we already know D is not right because it's different. All right, should we do one more? Just keep it going. Are you guys tired? You want to stop after this? Yeah.
Yes.
Okay. The graph of a function is shown in the following coordinate plane. Over what interval does the graph show a constant rate of change? Okay, so what keywords? So write it down, circle the keywords. And you guys can tell me what would the keywords be with?
Wait,
The keywords.
constant rate.
Yeah, constant rate of change. Nana, can you tell them what a constant rate of change is called in one word? No. Oh, that is actually true. But it wasn't the word I was looking for. The word I'm looking for starts with an S. We just talked about it.
Slow.
Slope. You are again. Yeah. Listen. All right. Slope. The slope is a constant rate of change. So which part of this graph? Oh, and slopes happen in a what? In a line. Slopes only happen in a line. They don't happen in a curve. Okay. So a slope is a straight line. It's an aspect of a straight line. And so which part of this graph is a straight line? Between P and Q, very good. So what's the correct answer? Get from P to Q. All right, so even though if I were you, having the education that you had this year, knowing how much homework you've done this year, I might look at this question and say, I've never seen a graph like that. Have you ever seen a graph like that? We don't really talk about graphs like this in 8th grade, do we?
No.
But does that mean you can't do the problem?
No.
No, because we talk about slopes? We do. And so can you look at the graph and tell me which part of it is a straight line?
Yeah.
And that's what they're asking you to do. So you just got to decode and figure out what they're asking. All right, I will make another video for the last 30 pages later. But that's all we're going to do for now. Bye, everybody.